Hello everyone, this is Professor Robert Solis and welcome to this video lesson. We're going to be talking about C++ classes. Well, first let me switch over here to Visual Studio so I can show you what I've got in terms of a header file. We've got this thing called sphere.h. We have sphere.cpp. We're going to call that the implementation file. And then we're going to have our main program that's going to utilize the class. Well, first of all, what is a class? A class is a collection of nouns and verbs. So in this case, the noun, for example, radius, right? That's a variable, and it's declared as a double. Now, I could create something that uses or acts upon this noun, and I'm going to create a function called getRadius and another function called setRadius. So typically what a class contains are functions and variables, and in this case you can see we have a constant over here. Now, some of those items are going to be available for everyone to use and some are not. So that's what this whole business of private versus public is all about. If you want something to be used in terms of your class definition, then you would put those items inside of public. If something is not to be used, maybe it's just supposed to be used strictly within the confines of your class, then we can call those things private. So the great thing about a class is that it allows you to hide how you are implementing a particular thing. So for example, let's say that I have a car. I don't know if there's hamsters underneath the hood. I don't know if it's hydrogen powered. I don't know if it's gasoline powered. I just know one thing. When I push on the accelerator, that thing had better move. So as long as the hood is closed, I am hiding how I am implementing, but nonetheless, the user knows how to implement acceleration. They simply push down on the pedal. And that's pretty much what a class allows you to do. So one of the things that you should note is that all classes have a constructor. Now a constructor is nothing more than a special method or a special function. And notice that it's the same name as the class. So over here we have the class called sphere. And the constructor is just simply that same class name with open and closed parentheses. We call this the default constructor. So in other words, when the program first runs, what are you going to do? This special function or the constructor is going to take care of that. Now, you can overload the constructor, and in this case, notice that we have that same name over here, constructor, which is the same as the class name, but this thing has some data within it. So this parameter is allowing the user to initialize the variable radius and when I first start the program. So what this does is it overloads what the constructor does. Like this constructor doesn't have any arguments. This constructor has one argument. So we call this an overloaded constructor. Again, what is a constructor? It's something that runs right when you start the program. So it's the first thing to be done, and then the rest of the program is going to be acted upon. All right, over here it looks like I have some functions. Some of these functions return items. Some of these functions are void functions in that they don't return anything. So those functions that are meant to obtain data, we call those accessor methods or getter methods. And those methods that are used to change something, we call those mutator methods or setter methods. So what I like to do is I like to put the word get or set to indicate what kind of function is this. Is this a getter or is this a setter? Now you may be asking, a getter or a setter of what? Well, check this out. So first of all, notice that I create this variable over here. It's radius and it's a double. And I want the user to be able to change or to read what this variable is. Now I can't access it directly because it's private. I've done that on purpose. This variable, I don't want anyone to be able to access it directly. I want to be able to determine if whether or not you get to read it or to set it. So in this case, I had better create a method or a function called getRadius. It literally reads this value. It's a getter or an accessor. And so what are we going to do? We're going to first of all read what this is and then send back its value. Well, since this is a double, that's exactly what I'm going to be doing. I'm going to be returning a double. Now, what about the idea of changing this value? Again, I can't get access to this because it's private. So what I'm going to do is I'm going to create a set radius function. Notice that this obtains a value, or I send it as an argument, and then I'm going to use the set method to change whatever that value is that I just sent to it. Okay, so we call those setters or mutator functions. All right, so this idea of private, you can think of this as, say, for example, you're going to a club and the owner of the club is in a corner and he doesn't want to be bothered. So you don't have access to him. He's in a private room and you'd like to talk to him. Well, if you want to get information from him, then we better talk to the bouncer. And so the bouncer is serving as either getting information, or maybe you give something to the bouncer that's going to give something to the owner of the club. He's the set bouncer in this context. So you want access to something private, then you had better create a getter and a setter in order to be able to read or write data to and from. Okay, and then of course in terms of a constant, we just simply capitalize all the letters. In this case, I am creating a constant for pi so that I can use within my program. So we call this the header file. Now, we want to implement, because you can think of this as a table of contents. This is what our class is going to contain. So we need to implement all of this stuff. It's kind of like a table of contents. Well, then we have to create the implementation file, which in this case is the same thing as the class name, sphere.cpp. Notice that we include this user-defined class. So we use the include keyword, and then we say sphere.h. Notice that it's enclosed within quotation marks because this is a user-defined header file. All right, so sphere.h means that we are going to include all of this stuff in our implementation file, sphere.cpp. All right, so over here, in fact, let me go ahead and split the screen, and let's see if I can go ahead and take this guy and drag it over here. There we go. All right, so it looks like for the header file, I declared getRadius. It's going to return a double. So notice over here, here's getRadius. It's going to return a double, but to access that, I have to type in whatever the class name is, followed with the scope resolution operator, which is quote colon colon, and then getRadius. Let me do this again so I can show you what I did initially. I typed in double. Sphere is the name of the class. Colon colon, and then you'll notice that a drop-down list appears. This is a drop-down of all of these items over here. Well, if I want to implement getRadius, I can simply double-click on this. This thing does not receive any arguments, as you see over here, so that's going to be open and close parentheses. Now I'm going to put an open and close curly bracket to indicate what it is that I want getRadius to do. All right, since I already created getRadius up here, I'm going to delete this, and now we have getRadius. And so notice what this thing does. It returns the value of radius. See, radius is private. I don't have access to it directly, but I can create access to it through this getRadius. And some of you may be asking, well, why not just give direct access to radius? Why create a getter or a setter? Well, there could be several reasons for that. Maybe you want to get the radius under only certain circumstances, or maybe you want to set the radius under circumstances. For example, I think maybe it's better if I explain it this way. Set radius is another function that allows you to change the value of the private instance variable radius. All right, well, in this case, you give me a value that you want me to change radius to, and I will determine if whether or not you are going to set it. How am I going to determine that? Well, first of all, if the radius parameter is greater than 0, yeah, then I'll allow you to change this private instance variable to whatever it is that you sent me. But if it's not greater than 0, then no, I'm not going to let you do that. I'll just go ahead and assign it to 0. So here's an example of why you might want to create a getter and a setter, because maybe you don't want to set this value based on what the user is intending on doing so. In this case, we don't want a negative radius. So if you send me a positive radius, then I'll let you make that assignment. But if not, I'm going to set it to 0. So that's the whole idea behind creating getters and setters. You have private instance variables that you may not want to be read from or set to a different value. So these getters and setters help control that. All right, again, with this set radius, how did I create that? Well, first of all, I just simply look over here and I'm pretty much just copying and pasting this entire thing, and then I'm adding in between sphere colon colon. So you'll notice that this over here is pretty much identical to this, except I added the word sphere colon colon because that's where the class name is, or the header file. And so this scope resolution operator allows me to access a particular member from this class, and in this case it's going to be set radius. And now it's time for me to implement it. So within curly braces, I implement what it is that I want to do. Well, I'm going to take this radius parameter and I'm going to assign it to radius if the radius parameter that you sent to me is greater than 0. And I do the same thing for all of the other functions. So in this case, I have calculate volume, it returns a double. So here's calculate volume rather, it returns a double. Sphere is the name of the class, colon, colon, allows me to access this function. And what am I going to do? Well, in order to calculate the volume, I'm going to return to you 4 divided by 3 times pi times, and then this is the power function, which allows me to raise the radius to the third power. So I'm returning back to you a calculation. Same thing over here in terms of calculate surface area. So you give me, actually, you don't even have to give me anything. I already know what the radius is because that's private. So within here, I can use this private instance variable within the power function to raise it to the second power times pi times 4. That's going to calculate the surface area. Now over here, this is our constructor. So the constructor, this is the way that you access it. Notice that you don't have anything before the sphere keyword, or the sphere class name, I should say. You don't see the word void or double or integer. What a constructor does is it executes initially when the program starts. Well, what do we want to do if a user instantiates an object that does not have an initial value? Well, what I'm going to do is I'm going to set the radius to 0. If you don't tell me what the radius is for this new sphere, let's say, for example, that we're creating a sphere called basketball, and you don't tell me what the radius is, well, I'm going to go ahead and set it to 0. That's what this constructor does. Now, this overloaded constructor, you're telling it what the initial radius is going to be. So say, for example, I'm going to create a sphere called baseball. All right, and you're going to give me an initial value of, say, for example, 1.5 inches. All right, so what I'm going to do is I'm going to create this baseball with a radius value of 1.5. Is 1.5 greater than 0? Yes, it is. Okay, therefore, the private instance variable that you don't have direct access to, I will allow it to be set to 1.5 because you met this criteria of it being greater than 0. So I have a constructor over here that can create a sphere that has no initial value that I've given to it, or perhaps I do give it an initial value. I have a way of accommodating both of those different options. Okay, so this is the implementation file. This is the header file. Now the source file is going to use this class. So the great thing about creating a class is that it prevents you from having to reinvent the wheel. I never again have to worry about recreating a program to deal with spheres in terms of calculating the surface area or calculating the volume, because I've already done that in my sphere.cpp implementation file. So now when I create a brand new program, such as over here, all I have to do is include the header file. By including this header file, now I have the ability to use all of the tools that are within this header file, or within the sphere header file. And what are those tools? Well, I can instantiate a sphere. I can give it an initial radius, or I don't have to necessarily give it an initial radius. So notice what I've done over here. So I create a main program, and within the main block of code, I'm going to instantiate Jawbreaker as a type of sphere. Now, what is Jawbreaker? It's a sphere. Now, notice that I don't have anything in terms of an open and closed parentheses over here, so this thing is just going to be assigned to 0. So what happens over here, it calls this constructor, and it says, well, let's just go ahead and assign the radius to 0. So this is what we call an object, and this is what we call a class. So an object is instantiated from a class. You can think of it as, say, for example, if I were to have you close your eyes and think of the word vehicle. Well, vehicle is a class. And one of you is thinking about a car, another one of you is thinking about a truck, another one is thinking about a motorcycle. Those are all vehicles. Those individual vehicles are objects, and those objects were instantiated from the vehicle class. Same thing over here. This is an object. This is a class. This is an abstract. It's when you close your eyes and you think about something, that's an abstract. It's an idea. And then when you actually put it down on paper, when you actually instantiate or create it, then it becomes a reality. And that's what this is a Jawbreaker. So we say that we instantiate object Jawbreaker as a sphere. Now, I've also instantiated another object called baseball. Now, for baseball, I'm giving it initial value of 2. So what this thing is going to do is it's going to instantiate the object baseball with an initial radius value of 2. So this thing calls this constructor over here. It assigns 2 over here, and then 2 is going to be assigned to radius. So here's an example of instantiating an object with no initial value. This is an example of instantiating an object with an initial value. All right, and then I'm also going to create a variable called radius temp, and I'm going to declare that as a double. All right, so what am I asked to do? So first I'm going to enter a radius value for the jawbreaker. So I'm going to ask the user to give me a radius value. I obtain that, and then in order for me to change jawbreaker's radius, what I do is I type in jawbreaker. Remember, that's my object over there, jawbreaker. It's a type of sphere. Jawbreaker dot. Okay, and then I have access to all of the different methods for jawbreaker. Well, one of the methods is this guy over here, set radius. So what set radius is going to do is allow me to give it some parameter. Well, whatever it is that that user typed in for the radius of the jawbreaker, that's what I'm going to be sending to set radius. And what does set radius do? It checks. Are you greater than 0? You are? Okay, so now you can change the private instance variable radius into whatever it is that you sent to me. So that's what this thing is going to do. Then I'll be able to indicate to the user that the surface area for the jawbreaker is, and so I'm going to see out jawbreaker dot, and then I'll get a drop down of all of the different options. Well, one of the different functions, I should say, is calculate surface area. Calculate surface area is nothing more than taking the radius and applying it to this equation. It's going to return that value. Whatever that value is, it's going to see out to the screen. The next thing we're going to do is we're going to say the volume of the jawbreaker is, well, once again, I have a function within my class called calcVolume. How do I access it? Well, whatever the name of the function or whatever the name of the object is, dot, and then I would get a drop list. And in this case, it's calcVolume. So let me give you a demonstration of that. Let me remove this calcVolume. Jawbreaker dot, and here's that drop list that I was telling you about. Well, one of the things that I have access to is calculate volume. So I double click calculate volume. This thing does not receive any parameters, as you can see over here, open and close parens. So I just simply put the open and close parens, and I send out that data. All right, let me run the program. And it's asking to enter a radius value for the jawbreaker, so I'm going to put 0.25, right? Quarter of an inch. It's kind of a big jawbreaker, half-inch jawbreaker, but anyway, 0.25. So it says the surface area of the jawbreaker is this, the volume of the jawbreaker is this. Press any key to continue. So the idea is that I am using the functions available for the sphere class to not only initialize the value of radius, but to calculate its volume and its surface area. And I can do that for jawbreaker. I can also do that for baseball. So I didn't enter any information about baseball, but if I wanted to, I could just simply indicate what the surface area and also what the volume is for this baseball by just simply adding some cout statements. So for example, let's say cout the surface area for the baseball is, all right, now I'm going to cout whatever that is, and that's going to be baseball dot, and then I'm going to, let's see here, I'm going to calculate the surface area, and it doesn't require any parameters, and then after I've done that, we'll say end-del to go to the beginning of the next line, and then let's do the same thing for the volume, so we'll say the volume for the baseball is, and we'll cout baseball dot, and I'm going to calculate the volume. So when I calculate the volume, again, it doesn't require any parameters, so I can just simply type in calculate volume with open and close parentheses, and then the end-del statement. So let me go ahead and run this program. Oops. Okay, I have some errors here. First, let me find out what's going on. I don't want to continue here. So let me go over here and find out what I did wrong. First of all, let me close this guy, and I'm going to go to build, rebuild, and let's see if we can find out what's going on. Rebuild all failed. what's going on here. So let me double click over here and let's see what I did. Oh, okay. I can see from the squiggly line over here, I forgot to put this operator here so that I can see out. Let me run the program again. There we go. All right, so 0.25, no big deal. But notice now that it says the surface area for the baseball is this, the volume for the baseball is this, based on the initial value of 2 being sent to the baseball. And that's it. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.